Welcome to Real Physics. This is a series of short clips about fundamental problems in physics, unsolved mysteries. And today we are talking about the proton-electron mass ratio, which is a number 1836.1526 and so on, measurable very precisely, but we don't know how to calculate it. But let's put this into a broader historical and epistemological context. If you have such an unexplained number, this is a problem. Today, physicists are happy with producing any numbers, lots of parameters in the standard model. But back then, people really considered this a fundamental problem. Einstein, for instance, said, "I can't believe that there is a good theory of physics in which a number appears that the mood of the creator could have just chosen in another way." So in his own attempts, for example, about the unified theory, if you look at this 1930 paper, in the very last paragraph, he says, well, the test of this theory will be if I'm able to calculate this relation, if I'm able to find solutions for the proton and electron. And also Paul Dirac, for example, for him it was a very big problem. He said, I have to calculate this number. He pondered for decades about the right model. He even discarded his own attempts for which he got the Nobel Prize and said this is the more important problem, to find solutions for the proton and the electron. Okay, and by the way, another general remark, I mean, if you calculate something and if you measure something very precisely, this is good physics. Good physics is not, here's a beautiful theory, I'm predicting black holes, here's a picture of a black hole. No, you predict a number with a margin of error and you measure a number with another margin of error, and if there is a good coincidence, that's a good theory. It's as simple as that. But that's not how today's physics works, and as I said, Dirac considered this a very important problem, and also Niels Bohr, obviously. An interesting point is that Niels Bohr said we need another revolution in physics, apart from the quantum revolution, for the atomic nucleus. Unless there is another turnover of all accepted concepts, we probably will not understand this strange behavior. And I think that, actually, if you want to understand the nucleus, you have to calculate that number. There is no good theory about the nucleus that does not predict that. You know, today people are talking about quarks. You know, I don't believe that. Read this very good book by Pickering or other stuff. This is something very essential which is missing, the calculation of the proton-electron mass ratio. Of course there are other mass ratios, but this is the most important one because we're talking of stable particles, and that's one of the most profound riddles of physics. If you enjoyed the video, give me a thumb up, and if you like this kind of fundamental problems, subscribe to this channel.